Okay, so here is a detailed walkthrough of the Pendulum project. So regarding the Pendulum project, in the end you're going to have about 4 outlines. You're going to have something called the research task. So you're going to write stuff underneath here. So you're going to have the research task. You're also going to talk about the theoretical background. You're going to explain the mathematics behind this, the physics behind this. So you're going to talk about the theoretical background. You're also going to talk about, you're also going to have what you call a research question. A research question, a hypothesis, followed by methodology, and lastly, for now at least, the apparatus or the materials used. So we're going to break this down into into 1, 2, 3, 4, 5, 6 steps for now, because the rest you're going to do at school. So let's look at the research task. The research task, let me denote it as RT here. The research task is written as an aim of sorts. So you write it as an objective. This is something that you want to do. So it's stated as an aim here. And so our language here is going to be to investigate. We want to investigate something. So to investigate what exactly? The effect of varying length on period squared, denoted as t squared, of oscillation of simple pendulum. You can rephrase it however way you want, but it's important to have these keywords. So to investigate the effect of varying length on period squared of oscillation of simple pendulum. So this is the instrument that you're going to be interacting with in the lab, a simple pendulum. But what exactly are you going to be doing? You're going to be investigating the effect of varying or changing length on period squared t squared of oscillation of simple pendulum. So this will make sense shortly. So now we can talk about the theoretical background. What is the physics behind this? How does it all relate? So let's talk about the theoretical background here. We have to explain the keywords. We have to expand on those. So I hear pendulum and I have to explain what that is. So you're doing this. So in science, your research should be reproducible. Somebody else should be able to follow your steps and reach the same conclusions as you. They shouldn't take your research on faith. So you have to explain these things as if you're explaining to someone who's outside the field, someone who doesn't know any physics. So first of all, I have to explain what a pendulum is. So in your theoretical background, you have to have something aligned to this effect that says a pendulum is an instrument used to measure time. An instrument used to measure time. So think a clock, think a sundial, think a stopwatch. Those are in the same category as a pendulum. But then they have to see it. You have to describe how a pendulum looks. So really a pendulum, so here you're going to say pendulum. How does it look? Well, when you say something is a pendulum, you are referring to a mass. This mass in scientific terms is called a bob. So a pendulum is a mass suspended. So let me do this. A pendulum is a mass or a bob suspended or hanging, so it's suspended from a fixed, it is a mass or bob suspended from a fixed point. We then go on to say it swings freely. This is the important part. It swings freely on an inextensible string. It swings freely on an inextensible string due to gravity. Due to gravity. We have to explain a few things. The word inextensible means that our string does not stretch. It means that our string does not stretch. So we are dealing with measurements involving length. So we have to be careful. We have to be deliberate regarding the string that we are going to use. You don't want a string that is elastic, in the sense that that string is going to give you false readings. So this string should be able to swing freely. The pendulum or the bob should be able to swing freely on an inextensible string, and it swings due to gravity because you have a mass or a bob attached at the end of that string. And so that was the description of the pendulum. Remember, we are still under the theoretical background. We just explained the use of a pendulum, an instrument that is used to measure time, very much like a clock or a sundial or something. And then we went on to describe the pendulum as if you are describing it to someone who has never seen it before. So it is a mass, or also called a bob, suspended from a fixed point. It swings freely on an inextensible string due to gravity. Now we are still under the theoretical background. We go on to say the time taken. So the research task mentioned the period. So we have to talk about the period under the theoretical background. So the period, what is the period? Well, the time taken. Period refers to the time taken by a pendulum. The time taken by a pendulum to complete one oscillation. But then here we are introducing yet another big word here, oscillation, and then we have to explain what an oscillation is. A complete movement of the pendulum. Complete movement of the pendulum. You want to make this thing accessible, but not too like detailed here in the theoretical background, but you want to make it accessible to someone who's not in the field. So period, time taken by pendulum to complete one oscillation. An oscillation is a complete movement of the pendulum. So this is just a bit of trivia here. My bad, let me just do this. So this is the complete swing of the pendulum from A to B and then back to A again. Just a piece of trivia there. So that's an oscillation. The theoretical background, maybe here we could introduce another paragraph to talk about the relationship now between the period and the length. We have to talk about the relationship between the period and the length. So once more, we are under the theoretical background. What did we talk about so far? We talked about the pendulum. That is the instrument that we're going to use. We described it. We then talked about the period. We introduced the period. We described we described one of the important ways that we are going to be dealing with here. Now we have to see the relationship between the period and the length, because that was stated in the research task. So let's talk about the relationship between the period and the length. So this is what we know. It is a fact that the period of pendulum, or the time taken by the pendulum to complete one oscillation, period of pendulum is influenced, or it is affected, it is influenced by length of string. It is influenced by length of string. Period of pendulum is influenced by the length of string. Mathematically, now this is where it gets a little bit complicated, but I promise you it's easy. So the period of pendulum is influenced by length of string and acceleration due to gravity, and acceleration due to gravity. So let's explain that mathematically. Let's show the relationship mathematically using a formula. What do we mean by this statement? Period, that's T, length, that's L, acceleration due to gravity is a small g here. So let's explain it mathematically. We are saying period T, so there is a formula that says T is equals to 2 pi square root here. Inside you're going to have L over G. T is equals to 2 pi square root L over G. But remember, the research task says we are dealing with period squared. So somehow here we have to introduce T squared. So let's just go ahead and square everything across on both sides of the equal sign. So T squared here, this is us introducing the squared, the period squared. And because we are saying what is on this side is equals to what is on this side, we are going to square this side too. And so it's just the basic arithmetic here. T squared is equals to 2. This 2 is going to be distributed across everything that is in this bracket. So 2 here, we're going to have 2 squared here, then in the end we're going to have 4. We're going to have 4 pi, and then this is going to be cancelled by the 2, and then we're going to have an L here at the top, the whole thing over G. So 2, the T squared is equals to 4 pi L over G. This is the formula that we are going to use in interpreting this thing, in interpreting this slightly complicated formula. We're going to say this shows that T squared is directly proportional to L. T squared is here at the top, L is here at the top. T squared is directly proportional to L. This simply means T squared, when you increase T squared, L should also increase, or the other way around, when you increase L squared, T squared is also supposed to increase. And in concrete terms here, we're going to say T squared is directly proportional. So let's just write that out. T squared is directly proportional to length. This is to say, we could restate and say, so directly proportional, this is to say they have a linear relationship. This is to say, in simpler terms now, if you were to draw a straight line, if you were to plot these things in a graph with T squared against L here, you would have a straight line that passes through the origin. They have a linear relationship, a straight line here. You would have a straight line that passes through the origin. This is what it means for these things to have a linear relationship. Now, in hindsight, after checking my notes here, I seem to realize that I've missed something here. So this pi should be squared. Remember, we distributed this 2 here across everything inside this bracket. So 2 squared pi should be squared here. So add that's minus 2 here. Okay. Now we move on to the research question. Now we move on to the research question. The research question, so the research question is a response to everything that we have covered in the theoretical background. We have learned some things in the theoretical background. We have learned that the period T of a simple pendulum is directly proportional to the length. That is to say, when you increase the length, the period also increases. And so that is what we've learned in the theoretical background. Now we respond to that by asking a few questions of our own. So question number 1, we're going to say, how does length of a simple pendulum affect period squared? How? This is what we want to figure out in the lab. How does length of a simple pendulum affect period squared? I mean, we already know that there is a linear relationship here, so we are in a way restating that. Number 2, we're going to ask, is the relationship between length and period squared linear? The physics say so, the math says so, but this is what we want to find out using research in the lab. So that is the research, that this makes up the portion under research question. And so let's talk about the hypothesis now. Basic science tells us that a hypothesis is an educated guess. So what is our hypothesis here? Our hypothesis says the T squared of a simple pendulum. So this is what we think. We think that the T squared of a simple pendulum is directly proportional to its length L. This is what we think because the physics says so. T is directly proportional to L. Who knows, maybe the experiment is going to prove us wrong. So this is us making an educated guess. So once more, to reiterate here, T is proportional to L just means that when you increase the length, T squared, so let me just put T squared here, my bad. So when you increase length here, T squared is also supposed to increase. There is a linear relationship between them. So let's move on to the methodology. And spend some time here under the methodology. Under the methodology, we are going to talk about things called variables. We're going to talk about things called variables. It's in the name, variables. So these are factors. These are things. So these are factors that can change. That can vary. These are factors that can change. These are factors that can vary during the investigation. So these are factors that can change. These are factors that can vary during the investigation. So let's talk more about variables and acknowledge the fact that there are 3 types of variables, namely the independent variables. We have the independent variable, we have the dependent variable, and we also have the controlled variable. So let's go into more detail regarding these. So what is the independent variable? Independent The independent variable, as the name suggests, it is not changed. Let's just write the definition here. No, let's just describe it. We deliberately, so here we deliberately change it to observe its effect. This is the variable that we deliberately change to observe its effect, in this case the L. So we're going to have a string, a shorter string in one instance. We're going to have a longer string in another instance, and yet another longer string here. So we're going to, length is going to vary. Length is a variable. Length is an independent variable. It is a type of variable that we change deliberately to observe its effect on what? On t². So this makes length an independent variable. So independent variable, and then our independent variable here is L. Let's talk about the dependent variable now. Dependent variable. So this is what we are measuring. So the dependent variable, this is what we are measuring. So you observe the dependent variable, you observe the dependent variable as a result of changing independent variable. So it makes sense here that t² is our independent variable, because we are changing the independent variable L in order to observe its effect on t². T² depends on this changing here. And lastly, let us talk about the controlled variables. Now the controlled variables, these are kept constant. These are factors that are kept constant. They could change, but you want to keep them constant in order not to interfere, in order to not interfere. Let's just say to keep the experiment fair, in order to keep experiment fair. So these are going to be kept constant. What are they? Well, the mass of the bulb. You don't want to use in one instant, you don't want to use a larger mass and then in another instant and then a smaller mass, because that would be introducing doubt into the experiment. You want to focus only on the length and its effect on t². So you don't go about changing the mass now. So you want to keep the mass constant, hence so this makes mass the controlled variable. You also want to keep the amplitude constant. Let's talk here for a few seconds regarding amplitude. So this is a simple setup. This is a simple pendulum, and this is your displaced amplitude. Amplitude in physics, we define an amplitude as the maximum. We define an amplitude as the maximum displacement of pendulum from rest position. This is, so let me just add here, maximum angular. It is an angle. We talk about an amplitude in terms of an angle. So the maximum angular displacement of pendulum from rest position. You have your pendulum here in the rest position. Once you displace it, once you change its point here, there's going to be an angle A. That's your amplitude. So the amplitude is the maximum angular displacement of pendulum from rest position. Now you don't want to you don't want this to vary too much. Obviously we're going to have to estimate it because you can't really measure this angle accurately in a lab, so we're going to be approximating it. So every time you're going to be displacing your pendulum by this much, so you want to keep the amplitude constant. And lastly, under the methodology, under the controlled variables, the third controlled variable is acceleration due to gravity. Acceleration due to gravity. And luckily for you, you don't have to do anything in trying to keep this constant because it is already constant for all objects near the Earth's surface. It is a figure is 10 meters per second squared for all objects near the Earth's surface. We could also go on to add air resistance and everything, but that's implied. So let's move on to the apparatus, the materials that you are going to be using. Apparatus. The apparatus, obviously you're going to need your pendulum. So you're going to need your pendulum bob, and then you're going to need your string, and then you're also going to need a retort stand and a clamp. So this is just the setup that looks like this. So this would be your table here, and then this is a retort stand and a clamp here, and then you're going to hang your string from here, and then this would be your pendulum bob. And then because a pendulum is concerned with time, you're going to need a stopwatch. And then because you are dealing with length here, you're going to need a meter ruler. And because this thing involves the amplitude, you displacing a pendulum, and amplitude is talked about in terms of angles, you're gonna need a protractor here. So the pendulum bob, this thing here, the string, this thing right here, the retort stand, this whole setup here, the stopwatch, and then the meter ruler because of the length, the protractor to measure the angular displacement of your pendulum. And then up next, I think you're going to talk about the steps, so they're going to give you those at school. That's all.